All right, so far we have looked at the basics of matrices. We've looked at adding and subtracting. We've looked at doing a scalar multiplication. Today we're going to look at how do you multiply two matrices together. Okay, so this process, like the calculation is not difficult, but the actual like process can be a little bit weird. It's a very kind of a bizarre process if you've never seen it before, but we're going to take a look at it and it won't be too bad. Okay, so the first thing that you need to know is that you can only multiply two matrices if the number of columns in the first matrix is equal to the number of rows in the second matrix. Okay, so how many columns there are here have to equal the number of rows that we have here. We'll talk about why in just a minute. This kind of multiplying is also called a dot product. So we would also refer to this the dot product of these two matrices. Okay. All right, so the first thing that you need to do before you even start these is you need to use the dimensions of the two matrices to decide if it's even possible to multiply, okay? Because remember, the number of columns has to equal the number of rows. So that's the first thing that you check for. If that's not the case, then our answer is just undefined, okay? And we would just move on, right? So that's kind of the idea. The process is not going to make much sense until you actually start going through it, but I kind of think about it as like tipping and multiplying and adding, all right? So that's the general idea. So let's take a look at this example and you'll kind of see how this falls out. So the first thing is I'm going to check the dimensions. So this guy has 4 rows and 2 columns. So this is a 4x2 matrix. This one has 2 rows and 3 columns. So it's a 2x3 matrix. Okay, so the first thing that we need to know is we need to know that the number of columns in the first one equals the number of rows in the second one. That's these two numbers. Okay, so these two numbers must match. If those aren't the same number, then it's just undefined and you can't multiply them together. Okay, so that's thing number one. The other thing that you can get from your dimensions is these guys here. So the 4 and the 3, okay, this is going to be the dimension of the new matrix, your resulting answer matrix. Okay, so in this case, it's going to be a 4x3. So our answer is going to be a 4x3 matrix. Okay, so that's the first thing that we need to check. So now we're going to actually multiply these matrices together. So here's what you do. You start by taking the first row of your first matrix, and we're going to multiply those numbers by the numbers in the first column of the second matrix. Okay, so I'm just going kind of one at a time. I'm going to do kind of like a step, and then I'll do what the final answer is going to end up being. So the first thing I'm multiplying is I'm multiplying the first number. So 7 times 7 is 49. And then I'm going to add to that the 3 times the 8. Okay, so I'm multiplying that. 3 and 8 is 24. Okay, so those are going to be my first pair of numbers. And then for my actual answer, I'm going to go ahead and add those together. So that adds to 73. Okay, then I'm staying with this first row here, but now I'm going to switch over to the second column in my next matrix, and we're going to do the same thing. So 7 times 4 is 28. 3 times 1 is 3. Okay, and then I add those together, so that works out to 31. Okay, and then same thing, stay with that first row, but I'm going to switch to the next column. 7 times 9 is 63. 3 times 5 is 15. And then I'm going to add those together, so that works out to 78. Okay, so there's my first ones. So now what I'm going to do is I'm going to kind of reset. I'm going to reset this guy back to the beginning, right? But now I'm going to move on to my second row. And then we're going to do the same thing. Okay, and I kind of call it tip, multiply, and add because it's like if you sort of envision taking these two numbers and tipping them on their side that way, that's sort of how the numbers match up, right? These two sort of tips on the side, right? The 2 would pair with the 7 and the 5 with the 8. So 2 times 7 is 14, and then plus 5 times 8 is 40. Add that together, that's going to be 54. All right, and then I'm moving, just like how I'm moving this little sticky thing, right? I'm moving over one row, I'm moving over in my matrix. So 2 times 4 is 8, and then 5 times 1 is 5. Add that together, that's 13. Okay, I'm moving over again, so I'm moving over here. 2 times 9 is 18. 5 times 5 is 25. So that's going to add to 43. Okay, then I'm moving like sideways, right? I'm moving back over here, and then I'm taking this guy and I'm moving it down one, right? So that means I'm going down to my next row. Same thing, 6 times 7 is 42. 8 times 8 is 64. So I'm going to add that together, and that is 106. Okay, move this guy over. 6 times 4 is 24. 8 times 1 is 8. That adds to 32. Move this guy over. 6 times 9 is 54. 8 times 5 is 40. So that adds to 94. Okay, then we're going to kind of reset this guy. So we're moving all the way back over here, and then we're shifting down one more. I didn't quite give myself enough room here when I drew my brackets in, so make that a little bit bigger. So 9 times 7 is 63, and 0 times 8 is 0. Okay, move over one. So 9 times 4 is 36. 0 times 1 is 0. And then move over one. 9 times 9 is 81. 5 times 0 is 0. Okay, so that is the answer. That's the dot product, what you get when you multiply these two matrices together. And you can see we said that our dimensions were going to be 4 by 3, right? Well, this is 4 rows and 3 columns. Okay. All right, so let's do that again with another example. So I'm going to kind of take my little sticky things. I think using something like this is kind of a really nice visual to help you sort of keep track of what you're doing. It took me a little bit to find ones that were transparent enough that you could see through them and put them on top. But something like that might be really helpful for you. You know, if you're struggling with keeping up with what's actually going on. All right, so the first thing that we're going to do before we start multiplying anything is we are going to check our dimensions, right? So when I look at this guy, this is a 2 by 3 matrix, and this one is a 3 by 2 matrix. So these numbers match, okay? And I'm expecting that my answer will be a 2 by 2 matrix. Okay, so my answer is going to be 2 by 2. All right, so let's go through this one. So this time we just have more numbers, but we're gonna do the same thing. So it's sort of like taking these 3 numbers and imagine tipping them on their side so they'd match up. So 1 times 0 is 0. 0 times negative 2 is 0. And negative 2 times 0 is 0. So hey, that just adds to 0. Okay, and then I'm gonna move over to the next column. 1 times 3 is 3. 0 times negative 1 is 0. Negative 2 times 4 is negative 8. And that all adds to negative 5. Okay, oops, sorry, lost my little guy. So we're going to come back, do this one, and this one. So 0 times 0 is 0. 3 times negative 2 is negative 6. Negative 1 times 0 is 0. So that adds to negative 6. And then same thing with this guy. 0 times 3 is 0. 3 times negative 1 is negative 3. And negative 1 times 4 is negative 4. Okay, so that adds to negative 7. So there's our resulting matrix. It's a 2 by 2. And there we have it. All right, then our last one here. So this guy, again, I'm taking a look at my dimensions. So this one's a 2 by 3. And this one's also a 2 by 3, right? So when we go to compare our dimensions, this doesn't work, right? They're not the same number. So I know right away that this is going to be undefined. Okay, so I've got that right away. It's going to be an undefined answer. You can't actually multiply them together. But let's take a look at why, right? If we were going to start doing this, we'd be multiplying these numbers and these numbers, right? So look at what happens when you do that. The 7 and the 1 would multiply, the 4 and the 0 would multiply, but there's no number to multiply the 9 by, right? So that's where the problem comes into play, and that's why you can't multiply these. So the number of columns has to equal the number of rows in order for it to work. All right, so that is how you multiply 2 matrices together. Okay, now there's one more thing that I want to go over really quick, and that is called the identity matrix. Okay, so identities are something that you have dealt with before many times. You may or may not have called them identities. Maybe in geometry you talked about it. Okay, but basically an identity is something that when you do an operation with it, it doesn't change anything. Okay, so for example, when we talk about addition with regular old numbers, right? Your identity is 0. Because whenever you add the number 0 to anything, it doesn't change anything, right? If I take 8 plus 0, it stays an 8. If I take -3 plus 0, it stays a -3. Okay, so that's what makes that the additive identity. Okay, if we talk about multiplying with regular old numbers, then our identity is 1. Because no matter what number you start with, if you multiply it by 1, right, you still stay at that same number. Okay, so that's what the idea of an identity is. Now, when we talk about with matrices, when you're adding an identity matrix, okay, it's just going to be all zeros, right? So if I have some random matrix, which I'm just making up, right, then its identity is just going to be all zeros, because when you add them together, that would make the number stay the same, right? So that's fine. So the adding identity is really easy with matrices, but the multiplying one is a lot more complicated, okay? Because if I want to take, say, this matrix 1, 2, 3, 4, and I want to know what do I have to multiply it by so that those numbers are going to stay the same, well, it can't just all be ones, right? Your first thought might be, well, make them all ones. But what's going to happen when we multiply those, right, is that we're multiplying these numbers, by these numbers, right? And our first thing that we would get is we get 1 plus 2, which is 3. So it doesn't stay the same, okay? So the trick with your identity matrix is that we need to have some zeros in here. Okay, I want this number to stay a 1, so I do want to multiply this one by 1. But I want this guy down here to be a 0, so that when I multiply it with a 2, I'm just adding 0 and that stays a 1. Okay, and then when I switch to my next ones, right, I want this number to stay at 2, right? So I definitely want these guys to multiply, but I want those to multiply to 0. So I'm going to make this guy a 0. So that now 1 times 0 is 0, and then 2 times 1 is 2, and that'll stay a 2. All right, and then if I go and look at these numbers here, and we see what happens. Okay, well now I'm multiplying the 3 times 1, so that's 3, and the 4 times 0, so that's 0, so that stayed the same. And then with this, guys, I'd multiply 3 times 0 is 0, and then 4 times 1 is 4, so that stayed the same. So this guy is my identity matrix. Okay, and now this should look kind of familiar to you. Remember when we were solving matrices, right? And we had it set up where we had ones on the main diagonal, and we had zeros everywhere else? That is how an identity matrix works when you're talking about multiplying. You want ones on your main diagonal and zeros everywhere else. Okay, so when we talk about an identity matrix for multiplication, first of all, they always have to be square matrices. Something like this, there isn't an identity matrix for. Okay, it's got to be a square matrix, so the number of rows has to equal the number of columns. Okay, so when we take a look at, say, a 2 by 2 matrix, right, it would just be 1, 0, 0, 1, like we just talked about. If it was a 3 by 3 matrix, it would be 1 and then some zeros, and then a 0 and a 1 in the middle, and then some zeros with a 1 at the end. Okay? If we wanted to have a 4 by 4 matrix, right, it would be a 1, bunch of zeros, then the 1 is 1 space over, the 1 is 1 space over, the 1 is 1 space over. So you can see the 1s are on a diagonal, zeros everywhere else. Okay, so those are your identity matrices, and if you multiply those by any matrix, it will always stay the same, provided, again, it's got to be a square matrix. Okay, so that is what an identity matrix is.